Welcome to another episode of my reviewer series for civil engineering topics focusing on geotechnical engineering problems. For this situation, after conducting a tri-axial test on a soil sample, the normal and shearing stress on the failure plane at failure were found to be 475 kilopascals and 350 kilopascals respectively. Determine the following: the minimum normal stress, the maximum normal stress, the deviator stress at failure, the angle that the failure plane makes with the horizontal, and the angle of shearing resistance. Before anything else, run through muna natin kung ano ba yung mga properties and concepts na need natin i-consider pag nag-a-analyze ng shear strength ng soil. As you can see, kumuha tayo ng isang soil particle mula sa soil sample natin na naging subjected sa isang tri-axial test. And looking at it in this dimension, ang dalawang main stresses na na-experience ng particle is yung normal or bearing stress, or the stress experienced due to perpendicular forces, and yung shear stress, or yung stress experienced ng particle due to parallel to its surface na forces. Now, looking at our unknowns, medyo logical na lang yung first two, which is yung minimum and maximum normal stress. Yung deviator stress at failure naman, this is just the difference between the maximum and minimum. And for our fourth unknown, the angle that the failure plane makes with the horizontal can be visualized as shown in the screen. As for the angle of shearing resistance, or also known as angle of friction, this is a property that can be solved by means of Morse circle. Before tayo mag-move ahead with Morse, let's understand muna kung ano yung difference ng dalawang angles na hinahanap natin. Yung angle of failure plane with the horizontal, it is actually the angle where the soil breaks. Kung makikita nyo, yung paslant na line na yan sa screen is actually yung imaginary line kung paano siya mahati if na-reach niya na yung limit ng force applied. On the other hand, yung angle of shearing resistance naman is the angle maximized sa pag-resist ng sliding ng soil when it reaches failure. Yun din yung reason kaya siya natawag na angle of internal friction, dahil nga sa sliding na mag-occur. This time, move on na tayo sa method na gagamitin natin para ma-determine ang mga values na to. As stated, gagamitin natin para dito is yung method of Morse circle. And in order to perform our solution, define muna natin yung parts ng illustration. Sa Cartesian plane kung saan natin i-graph yung circle, yung horizontal axis natin will serve as our normal stress axis. Then yung vertical axis naman is para sa shear stress. Given tayo ng failure value na 475 kPa normal stress at 350 kPa shear stress. So, plot na natin to sa graph. And since wala tayong cohesion value, ang failure plane natin ay magsisimula sa origin ng figure. Take note, plane failure natin is a tangent line to the circle na bubuuin natin. Therefore, this failure plane is perpendicular to a radius of the circle. Since buo na yung figure, define na natin yung parameters. For our minimum normal stress, siya yung nakalocate sa nearest point ng semicircle towards the origin. We will denote that as sigma sub 3. As for the maximum normal stress, siya naman yung nasa farthest point, and we will denote that as sigma sub 1. Now, I know possibly medyo curious or confused yung iba sa inyo kasi ba't di natin usually ginagamit yung sigma sub 2 bago yung sigma sub 3? And the reason for that is, yung sigma sub 2 is usually used for 3-dimensional analysis. Mapapansin niyo yun madalas, especially sa mga textbook references. Since horizontal and vertical analysis lang ang pinaperform natin sa soil particle, di pa talaga natin madedetermine yung sa stress experience sa ibang phases ng particle. So going back, Para naman sa distance between sigma sub 3 at sigma sub 1, which is also the diameter of our circle, yun naman yung deviator stress at failure natin, which we will denote as delta sigma. Kung bakit delta yung attached na symbol, it's just because yun yung usual na ginagamit for change or differences in value. For the angle of failure plane naman, kung ipoposition natin yung plane sa Morse circle, pwede natin siya i-locate from point ng minimum normal stress to point ng failure stresses. Therefore, dito naman natin madetermine yung angle niya. And lastly, for the angle of shearing resistance, dito lang natin siya kukunin sa failure plane, coming from the horizontal axis. From this point forward, we would just simply apply geometry para ma-determine yung mga values nila. Ang technical part about Morse circle talaga is if di ka sanay na mag-solve ng mga geometric problems, medyo mahihirapan ka i-visualize kung paano mo kukuhin yung measured values. So, tamang practice din pag may time guys. Di nyo lang to actually magagamit sa MSTE but also sa subject na HGE once na mag-take na kayo ng board exams. Actually, magagamit nyo nga rin yan sa PSAD for some other topics. Pero syempre, least muna tayo dun for now. Game tayo sa pag-solve ng number 1. Para lang madali yung ma-visualize, separate muna natin yung ibang parts ng circle and utilize muna natin yung given values. So we know na using 475 kPa and 350 kPa measurements, pwede tayo makabuo ng triangle and yung slope ay i-denote natin as the letter L. Visualizing the figure at a different angle, pwede tayong makabuo ng isa pang similar na triangle na involved naman not just yung slope L natin, but also yung radius ng semicircle. And in order to determine the values of our variables, pwede natin to gamitan ng method of ratio and proportion of similar triangles. Para medyo makita nyo lang yung pagiging proportional ng mga triangles, i-flip ko lang tong figure ng second triangle natin. And actually, bago natin i-apply yung ratio and proportion method, pwede na natin makuha yung value ni L by performing Pythagorean theorem, where yung hypotenuse natin, or yung L when squared, is just equal to the opposite side squared plus adjacent side squared. Solving for the value, yung slope L natin is approximately 590.02. And ang gagamitin natin is kPa since yun yung mga unit ng values na sinasolve natin. Moving forward, applying the ratio and proportion method, we can say that side 350 over side 475 is proportional to the radius side over the length L. And upon solving, we will get a radius value of 434.752 kPa. Performing another ratio and proportion method, but involving naman yung side na present yung sigma sub 3 natin, we can say that the quantity of the slope sigma sub 3 plus radius r over the radius r again is proportional to 590.021 over side 350 as shown in the rewritten figure. Solving for sigma sub 3, ang makukuha nating value is 298.142 kPa. At this point, madali na lang natin makukuha si maximum and deviator stress since for our deviator, diameter lang siya ng circle. So gagawin lang natin is 2 times radius and we'll get a value of 869.504 kPa. Then, para naman sa maximum normal stress, add mo lang yung deviator kay minimum. Doing so, we will get a value of 1,167.647 kPa. Next naman tayo. Sa angle of failure plane, looking at it at the slope formed from sigma sub 3 to 0.475, 350, pwede tayo bumuo ng right triangle. Then para malaman yung value ng angle, Gamitan lang natin to ng trigonometry. Separating the triangle from the figure, we know that the height of the triangle is 350 and the base naman can be determined by subtracting the minimum normal stress from 475. Applying that, yung value ng base natin is approximately 176.858. And in getting our angle, since ang present na sides ng right triangle is yung opposite and adjacent, ang gagamitin natin na trigonometric function is tangent theta. So, writing it in formula, tangent theta is equal to our opposite, which is 350, over our adjacent, which is 176.858. Solving for the value of theta, para makompute sa calculator, we just type in the arctangent of 350 over 176.858. That gives us a value of 63.192 degrees. So okay, last na. For our angle of shearing resistance, same lang gagawin natin na kukuha lang tayo ng right triangle ulit sa figure. Tapos apply natin ulit yung trigonometry. So for this one, ang opposite side is 350, then ang adjacent side is 475. Solving for the angle using the function tangent theta, we will get the value of 36.384 degrees. So tapos na natin sagutan lahat ng questions. But meron pa tayong pwedeng i-consider na formula para sa pag-solve ng mga angles natin. Para lang may idea yung iba sa isa pang alternative na solution, ang angle of failure plane natin with the horizontal is actually equal to 45 degrees plus our angle of internal friction divided by 2. So technically speaking, may relationship talaga yung dalawang angles. And that would be further explained na lang once na nag-release na ako ng lecture videos. But for now, that's it for this episode. Feel free to ask in the comments if may questions kayo. Bye guys!